Alright, so in this video, we are looking at 9618 variant 43 of October, November 2023, and we'll be doing the Python solution to question 3 of this paper. So let's go ahead and look at question 3 here. So we are given a class diagram that represents a computer game that is going to be created. So we have this character class that represents a character in the computer game, as it were. So you see that by now you should know that the first section are the fields inside of the character class, and the second section down here would be the methods or the functions inside of the character class, as it were. So our task here is to write program code to declare the class and its constructor, and we are not to declare any other methods. So let's actually go ahead and look at that implementation there. So you see that on line 4, that's where we have the class definition for character, and we are initializing the constructor to have 3 variables. That is the name, it's going to be a string, right? Then the x position is going to be an integer, then the y position is also going to be an integer. Then we are just setting the values to whatever has been supplied inside of the constructor right there. Then one thing that you might notice is that that might be conspicuous to you if you did follow along with my Python series. You might realize that we are missing these values. Like for instance, we are missing a value called, say, name. Then maybe I would set it to an empty string. Then x position, I would set it to maybe say 0. Then y position, I would set it to 0 again because it's an integer. Right? You might notice that this is missing from my class right there. Right? So this essentially it's redundant in Python, to say the least. If you are going to create a class, you can just define the functions inside of the constructor, sorry, the variables inside of the constructor right there, and your program will still work all the same. So this is why I'm not using the notation that I'm not using these. I'm not rather declaring these variables right here first, then using them inside of the constructor. Easy. So you can just go ahead and do it straight away inside of your constructor, as it were. So let me just select these 3 lines and comment them out because I don't need them in this case. I just wanted to comment on it why I'm not using this notation right there. It's redundant, so that's why I'm just declaring my variables straight inside of the constructor right there. And you might actually see me doing this in other videos, right? So just remember that. All right, so of course we'll be done with the class in this constructor, so you copy the code and paste it inside of the evidence document. The next up, we are to have the get x and get y position functions. So let's go ahead and look at the implementation there. So on line 16 to 20, that's when we have the get x position, then the get y position. Then of course they are going to return integers, so that's why we are using that arrow function to show that they are going to return integers. So this is going to save us having to comment out everything that our function does. So you can just use that notation right there. So you of course copy the code and paste it inside of the evidence document. Then moving on to item number 3, we have to do set methods, set x position and set y position. But we are not just going to set the position, is it? We have to make sure that these values that are being set, after setting a value, it is not less than 0 or it doesn't exceed 10,000. So this is what we are essentially going to have to test inside of our set methods. So for the set x position, right, we are going to take a value. When we call set x, then it's a void function. So the return type is none right there. Then if a constructor, you don't need to use the arrow none, because a constructor doesn't return anything. It's only there to construct or to create a new object. So you don't need to put the arrow none on a constructor. You only put it on values that are void functions, as it were. So set x is a void function. So it's actually going to return none, is it? So that's why we are putting none right there. So we take a value x, rather a value, an integer value right there. Then we add it to the x position, right? So if the new value for x position exceeds 10,000, we're simply going to revert it to 10,000. Then if the new value for x is also going to be less than 0, we are just going to set it to be less than what? Less than 0. Rather to be equal to 0, not less than 0. Sorry about that. So we also do the same thing for the set y position, right? It's exactly the same implementation, only the different function name right there. So of course, having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then the method move takes a string parameter, up, down, left, or right. Then depending on the parameter that would have been passed, we are to make adjustments, or rather we are to pass these values 10, minus 10, minus 10, and 10, depending on the situation is. So let's actually go ahead and look at the implementation going on there. So as of Python 3.5, they introduced the match case construct, which is equivalent to switch cases in other languages, and it's also equivalent to the case of in pseudocode. So instead of having to chain if a bunch of if statements, you can just make use of the match case because it's more cleaner the syntax. So you see that we're using a match case as it were. Then again, it's a void function that takes a string called direction. Then we are going to convert direction to lowercase. Then in the case that direction is up, we are going to set the y position or adjust the y position by 10. If the direction is down, we adjust by minus 10, and so forth and so on. Then in the case that we have an invalid value that was specified, we're just going to default to this print invalid selection right there. So we are using this nameless variable right there. So this simply means that for any other case that we didn't specify up there, right, it's just going to default to this case on line number 49, and it's going to print invalid selection or invalid direction as it were. So of course you'd copy the code and paste it inside of the evidence document. Moving on to part B, we are to write program code to declare a new instance of the character with identifier code check, and we are to pass those values when you create that object. So set x position is going to be 50 and y position is going to be 50. So let's go ahead and look at that in the main method down here. So on line 77, that's where we are actually creating the object called check from the character class. So you see that we have the character class. This is actually now the character constructor, isn't? So we are passing jack 50 and 50 because the constructor, remember, it takes 3 arguments right there. So the x position, the y position, as well as the name of the character. So you can go ahead and copy the code and paste it inside of the evidence document. Then moving on with the solutions, you are to create a class called bike character that inherits from the character class. So it has a constructor that's going to call its parent class constructor with the appropriate values. Then it also has a move method that's essentially going to override the move method from the parent class because this one is going to adjust by 20s instead of 10s. So coming to the bike character class, right, this is how you show that a class inherits from another class in Python. You pass that the class the superclass is a parameter to the class definition of the class that extends, or to the subclass as it were. So the subclass is by character, then the superclass is character. So the constructor right there, you see that it matches what we've been told here. But then again, it needs to call its parent class constructor. Is it? So here on line 57, we are calling the super class is constructor, which is init name, x position, y position, and so forth and so on. Then of course you copy the code and paste it inside of the evidence document. Moving on to item number 2, we are to implement the move function that does things a bit differently. Rather, it doesn't do things differently at all. It just changes the values with which you can adjust the position. So it's adjusting by 20s. So here you see that it's exactly the same implementation as inside of the character class. The only thing that's different is that we are passing 20, minus 20, minus 20, and 20 respectively for the different directions, is it? So you just do that, and essentially your move function is overridden, is it? It's unlike in Java where you have to use the override notation. You don't need to do anything. You just declare a function with the same name, and that's the one that's going to be called. Then we are to write program to instantiate an object called color of the bike character class, and we are going to pass the x position as y and the y position as 50. Is 100, sorry. The x position is 100 and the y position is 50. So coming to the implementation there, you see that we have the color object and we are calling the bike character constructor and passing the values as specified in the question paper. Then we have to write program code to take as input which of the two characters the user would like to move. So let's do this step by step. So here we are prompting, we have the user interaction section. So the user inputs a character, right? They have to choose between Jack and Carla. Then we're simply going to strip it of any white spaces and convert it to all lowercase. Then we do the same thing for the direction, right? Because we're also going to take the direction as the second bullet point right there. So we take the direction. Now we have the chosen character in the direction. Then in the case that the chosen character is Jack, we are going to move Jack in the specified direction. Having done that, we are also going to, so now we are calling the appropriate method to move the character, right? That's what we are doing right there. Then we also need to output the character's new X and Y position in an appropriate format. Like for example, they specified the format for us there. So we can just go ahead and F print this. So Jack's new position is, then we call the get X position and the get Y position on the Jack object. Then in the case that the chosen is Carla, we do the same thing, right? Outputting the X position and the Y position using the get and set methods, rather the get methods that we created inside of the character class. Then having done that, we have to test our program with Jack right and Carla down. So let's come back to our script. And so of course on line 96, 97, we are calling the main method. Then let me open the terminal. So we have to invoke the Python interpreter and we wanted to run the question n23 underscore v43.py file, which is exactly the file that we have right here. So you can see the file name right there. So run the program. Okay. All right, I'm missing a T there. So that's why I got that error. Let me put that T there, then hit enter. Still I'm getting an error, no such file. Okay, n23 question 3. Oh yeah, I'm missing the question 3 right there. I was in a hurry. All right, so there we go. We have to choose Jack, and Jack is going to move right. So that's his new position. Then we run the program one more time, and this time around we choose Carla, and Carla is going to move down. Then the new position is going to be that. So you would go ahead and take a screenshot of this output and paste it inside of the evidence document. So that does it for the solution to question number 3. And also that does it for this question paper. So hopefully you learned something, and I'll see you guys in the next one.